Welcome to the Explainer. So, hospitals cure patients, right? But they also produce some of the most complex, pathogen-rich wastewater on Earth. Today, we're taking a seriously fascinating trip. We're going to follow a single drop of highly contaminated hospital wastewater on an incredible journey through an effluent treatment plant. But we're not just looking at pipes and steel tanks here. We're zeroing in on the biological science that makes the whole thing tick. Specifically, we'll be looking at the incredible microscopic ecosystems we engineer to clean our water. It's all about the science behind MBBR tanks today. Here's our roadmap. We'll quickly cover the initial challenge, then dive deep into the MBBR engine, explore the science of biofilm bacteria, look at separating sludge from water, touch on final filtration and disinfection, and wrap up with the safe discharge. Section 1. The challenge, taming the flow. We're starting right at the source, the exact moment raw, hazardous wastewater exits the hospital drains. Now, hospital wastewater isn't just liquid. It carries a ton of actual physical debris. We're talking cloth, plastic packets, large solid waste, even discarded cotton and gauze. So the very first line of defense is the bar screen. Think of it as a physical bouncer. It catches these large, visible solids right away, so they absolutely do not destroy the delicate biological ecosystems we'll be relying on later. Next up, the water hits the equalization tank. Hospital water output is frankly all over the place. Sometimes there's a massive rush, other times barely a trickle. This tank holds exactly 4.37 cubic meters of volume, which gives it roughly a 4.6-hour hold time. Its whole job is to mix and steady the flow. We have to do this so that sudden surges of pollutants don't completely overwhelm the delicate biological treatment coming up next. Okay, so we've removed the plastic, the gauze, the physical trash. We've steadied the flow, but that leaves a massive question. How do we destroy the invisible organic waste? You know, the toxic matter that you can't just scoop out with a net? That brings us to Section 2, the MBBR engine, the biological heart. This is the absolute core of our explainer today. Understanding MBBR, which stands for Moving Bed Biofilm Reactor, is absolutely crucial. It sounds super technical, right? But it's essentially a dedicated, engineered home for a hungry bacterial army. Instead of using harsh chemicals to dissolve organic pollution, we literally just let nature do the work. The tank is filled with tiny plastic media. These little plastic pieces act as houses, allowing naturally occurring microorganisms to attach and build a tightly packed biofilm. And crucially, these beds are constantly moving around in the water. That relentless motion physically shears off the dead, older bacteria on the outside of the film, constantly exposing fresh, hungry bacteria to the water. They just relentlessly feed on the biochemical and chemical oxygen demand, the BOD and COD in the waste. It's an amazing piece of biological engineering. And to guarantee results, we actually use a two-stage biological attack. On one side, MBBR1 is our heavy lifter. This is where the primary biological treatment happens, breaking down the vast majority of that heavy organic matter. But, well, nature isn't always perfect, so the water then flows into MBBR2, which acts as a relentless polisher. This second stage ensures any surviving organic pollutants are hunted down and completely destroyed. It drastically improves the final quality of the effluent. Together, these two reactor tanks provide a massive 5.04 cubic meters of volume. To put that into perspective, that's roughly the size of a large commercial delivery van, purely dedicated to microscopic warfare. Billions of bacteria tirelessly purifying the water every single second. Moving on to Section 3, the science of biofilm bacteria, life support for the army. Because here's the catch. This bacterial army can't just survive on its own. Just like us, these bacteria require oxygen to breathe and metabolize their food. Let's look at how we build the perfect life support system for them. It's a really precise sequence. It starts with a powerful air blower, pushing ambient air through a dedicated pipe down into a grid at the base of the tank, and finally through a diffuser straight into the MBBR tank. This constant, engineered flow of oxygen is exactly what keeps that biofilm alive and aggressively eating the pollution. The key piece of tech here is the fine bubble diffuser right at the bottom of the tank. You might wonder, why fine bubbles? Well, smaller bubbles actually have an exponentially larger total surface area than large, chunky ones. And that means drastically better oxygen transfer efficiency directly into the wastewater. More dissolved oxygen means our bacteria have a higher metabolism, which makes them work much, much harder to break down that toxic waste. Section 4. Separating sludge from water, gravity at work. So the bacteria have feasted on the organic pollution, but now we're left with a brand new problem: biological sludge. This sludge is essentially the physical byproduct of all those well-fed bacteria, and obviously it needs to be removed from our newly cleaned water. Enter the secondary clarifier. In this tank, we stop agitating the water and simply let gravity take over. Because the biological solids, the sludge, are heavier than water, they naturally sink right to the bottom of the tank. Meanwhile, the relatively clear, treated water gently floats up to the top. It's a highly effective, elegant physical separation right after the intense biological chaos of the MBBR tanks. We then carefully pump that settled sludge out from the bottom using a sludge transfer pump. Now, this relies on a strict one running plus one standby system. Redundancy is absolutely critical in hospital waste management. If one pump ever fails, the backup instantly kicks in so the plant never stops. The sludge is then sent to a holding tank or a dewatering system, ensuring it's properly and legally managed according to strict environmental guidelines. Section 5. Final filtration and disinfection. Polishing the water. The water floating at the top of the clarifier is now biologically safe, meaning the organic pollution is gone, but we aren't quite finished yet. It still needs a final physical and chemical polish. After resting briefly in a 1.79 cubic meter filter feed sump to build up pressure, the water is forced through two specialized filters. First up, the pressure sand filter. This acts kind of like an underground aquifer, using dense layers of gravel and sand to trap any lingering microscopic suspended solids. Then, the activated carbon filter takes over. This works like a microscopic chemical sponge, perfectly stripping out bad odors, unnatural colors, residual organics, and any chemicals the bacteria might have missed. Finally, we reach the chemical dosing and disinfection tank. Precision is everything here. Specially calibrated pumps inject the absolute perfect measured amount of chemical disinfectants, things like sodium hypochlorite or chlorine, into a contact tank. This completely eliminates any lingering harmful pathogens, viruses, or microscopic threats that somehow survived the biological and filtration stages. We absolutely cannot afford to release anything dangerous back into the municipal water system. Section 6. Safe discharge, the final release. With that final chemical sweep, we've successfully reached the end of the line. The digital flow meter tracks this ultimate success in real time. It proves that this precisely engineered system can safely discharge an impressive 22,800 liters of treated water every single day. To put that into perspective, that's enough to fill an average backyard swimming pool. Flowing continuously at a rate of 0.95 cubic meters per hour, that is a massive volume of water reclaimed and rendered entirely harmless. But it's vital to remember that none of this works in isolation. Behind the scenes, the automatic control panel acts as the electrical brain of the plant, seamlessly managing the pumps, blowers, and timers, complete with built-in overload protection. Meanwhile, the complex network of interconnection piping, all those valves, elbows, and flanges, acts as the circulatory system to keep the whole operation running smoothly. To summarize this incredible multi-stage journey, we move from the physical screening of large solids straight into the biological MBBR engine, where billions of bacteria devour the waste. We separate the resulting biological solids via gravity, filter the water under high pressure, chemically disinfect it, and finally, discharge it safely back into the environment. It really leaves you wondering about the sheer power of the unseen microscopic world. If a tiny, engineered army of bacteria in an MBBR tank can be harnessed to transform hazardous hospital waste into clean, safe water, what other invisible ecosystems are out there, secretly protecting our planet? Thanks for joining this explainer, and keep exploring the science around you.